This example is asking us to use linearization, that's one bit of language that they use to set up this problem, to approximate this given square root value down here. They'll use the term linearization. They'll also use the term tangent line approximation. They will use the term, what else do they use? They like to use the term local linear approximation. So again, the wonderful news about math is they like to say the same thing in 20 different ways. So all three of these things are asking us to do the same process. They're asking us to basically create the equation of a tangent line that we will use to approximate a function. So step one of the process is we got to define what that function is. So we are looking to create some approximation of an equation. Well, the equation we want to do here, it's always going to be the equation of whatever you're plugging the number into. So when you look at this, in order to evaluate 4.14, I would need to plug that into the square root function. So my square root function is the f of x. It's going to be the equation that we are going to approximate with the tangent line approximation or with our linearization. Step two of the process is we need to find a point that we're going to get really close to that we can do the math easily. So what you're looking for right now is you want something that is close to 4.14, but that if you plugged it into the f of x you just created, you could do the math in your head real quick, right? So what we want to do is we are going to use an x value, an x naught value. Sometimes they call it the a value. Again, depending upon where you're at, they'll refer to it slightly different. They'll use the term centered at to describe this. All of these things, again, meaning the same thing, which is what's the x value that's really close to the x value you care about that you could do the math of in your head easily. So in this scenario, I could find the square root of 4 very easily. It's the closest number to 4.14 that I can find easily in my head. Now we get into step 3 of the process. Step 3 of this process is just like finding the equation of a tangent line. That's all we're really doing here. They wrap it in some different language, but it's still the same thing. Sometimes they like to use this, create a linearization equation. L of x is equal to, and then if we look at this right now, f prime of x naught times x minus x naught plus f of x naught. Guess what? This is the exact same thing as point slope form. This is y equals m times x minus, we call it x1 when we're doing our point slope form, plus, and then f of x naught, that's just y1. It is the exact same process. Creating your linearization equation is the exact same process as creating your tangent line approximation. So the first thing we're going to do, we're just going to follow the same set of steps we follow for finding the equation line, the equation of the tangent line. Step 1 of that process is we need to find the point on the graph. So we need to find our x and our y right now. So to do that, we take the x value that we know we can do the math in our head. So our x naught value in this is 4. To find the point, we plug it into the f of x that we're approximating. So we want to know what is f of 4 equal. So everywhere we see an x, we plug in 4. So then we get the square root of 4 is 2. So out of there, we are going to get that we have an x value of 4 and a y value of 2. So x1, y1. Step 2 of the process is we need to find the slope. We need to find our m. And in calculus, our slope formula comes from our derivative. So to find our slope, we need to find the derivative of our equation. So again, start with the f of x that you're working with, the equation you're approximating. So f of x is equal to the square root of x. Before we find the derivative of that, we need to rewrite that root. Anytime you see a root in a problem, that's going to be a rewrite that you need to do. So the rewrite on this is our power over root rewrite. Anytime you have x to some power inside a root, you rewrite that as x to the power divided by the root. So the rewrite on this is going to be x, that's a power of 1 and a root of 2. So x to the 1/2. That's a rewrite only, no derivative. Now we're ready to actually go find our derivative. So to do that, that's just a straight up power rule. So we're just going to bring our power down, bring the 1/2 down in front. X, subtracting 1 from the power gets us negative 1/2. So this is our equation for finding our slope right now. We then find our slope at the point we care about, this specific x value that we're talking about, the one that we can do the math of in our head. So we want to know specifically what is f prime of 4. So we get 1/2 times 4 to the negative 1/2. And so out of there, what we're going to get is we're going to get 1/4. 1/2 times 1/2 gets us 1/4. This is our m. This is our slope that we need to create the equation of our tangent line. So now we'll go to step 3 of the process, and we'll actually create the equation of our tangent line. So they might call it, again, they might call it L of x, your linearization equation. So your linearization equation is going to be your slope, so point slope form, right? 1/4 x minus your x1 value or your x0, whatever they're calling it, that is the 4 that we started with, plus, and then your y1, which is 2. So using our point here. So this is our linearization equation. That is what we're going to use. Essentially what we've done is we've now created an equation that approximates our starting equation. So the square root of x is approximately this L of x equation. So to use that now, what they wanted us to do, notice that they used the term approximate up in here. They didn't care if we got the exact value of the square root of 4.14. What they want is an approximation of the square root of 4.14. So plugging 4.14 in for x, what you're going to see is the square root of 4.14 is approximately L of 4.14, which we get by plugging R in for x, 4.14 minus 4 plus 2. So in the end, you'll get 4.14 is approximately whatever that math is that you do right there. Shove that into your calculator, and you're going to get out, or do it by hand if you need to, 2.035. And so that is your final answer at that point. So really, anytime they want you to use linearization, do a tangent line approximation, this is the same exact process that you use to find the equation of a tangent line. You find the point that goes with your x value, you find the slope by plugging that x value into the derivative, you create your linearization approximation using the formula that we have here. The only difference is you have to know what f of x to use to begin with, and you have to choose your own x value or your own centered at value, a value really close to the number they care about, but that you could do the math of in your own head. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.